A good day to all of you, and I welcome you in this course on Introduction to Engineering Thermodynamics. Engineering thermodynamics has a lots of application. So this subject will help you to understand lots of application and various concepts related to the thermodynamics. Firstly, we will start with the definition of the thermodynamics. We will understand what is thermodynamics, and then later on we will understand application of the thermodynamics, and further we will understand what is microscopic thermodynamics and what is macroscopic thermodynamics. So let's begin with the thermodynamics. So introduction. What is thermodynamics? Thermodynamics is basically made up of two words. One is thermi, which is a Greek word which means is heat, and another word is the dynamics, which means force or motion. So the heat that is used to produce force or motion is called as the thermodynamics. Let's look at some of the definition of the thermodynamics. Thermodynamics is the science of energy transfer and its effects on the physical properties of the substance. It is based on the observation of common experience which have been formulated in the thermodynamics law. Now let's look at some of the more definitions which are related to the thermodynamics, and then that will make you to more clear picture about the thermodynamics. So the science of energy that concerned with the ways in which energy is stored within a body is called the thermodynamics. It is basically related to the energy transformation, and most of the energy transformation that is involved in here is the heat and work movement. And the fundamental law is the energy conservation law, which states energy neither be created nor be destroyed. It can only be converted into the one form of energy to the another form of energy. So I hope that you understood what is thermodynamics. Now let's look at the applications of the thermodynamics. So it has lots of application. We will be look at some of the applications. First one is the steam power plants. Steam power plants are known as the thermal power plants also, and these plants are used to convert the heat energy into the electrical energy or to produce electricity. As you can see, these are some of the components of the simple steam power plants, and all these components are interact with the heat and work. Another good application is the nuclear power plants. Nuclear power plant is use of nuclear reaction to produce electricity. Nuclear power can be obtained from the nuclear fission, nuclear decay, nuclear fusion, and it is a clean and efficient way of boiling water to make steam, which turns the turbine to produce electricity. So it is basically a kind of electricity production, but to generate electricity, we use the nuclear reactions. So it has a good applications of the thermodynamics. One more good applications of the thermodynamics is the internal combustion engine. All the engine, that is petrol engine, diesel engine, gas engine, all are the good applications of the thermodynamics. Internal combustion is a heat engine in which combustion of fuel occurs with the oxidizer, and that oxidizer is usually air. In a combustion chamber, that is an integral part of the working flow circuit. So this is the application of the thermodynamics. Let's look at some of more application. Domestic refrigerator that we used in which we absorb the heat. Okay, so refrigeration is basically a cooling process which occurs when the liquid refrigerant absorb heat by the evaporation, generally at the low temperature or the low pressure. One more application we are having the room air conditioner, and room air conditioner working is similar like air conditioning refrigeration system, but here we remove the heat as well as we control the humidity also. Okay, and the device that we use to control the heat and the humidity, we call to the room air conditioner. So these are the few largely used applications of the thermodynamics, but they've categorized all these applications into the two categories. One is the household application, another one is the industrial applications. Household applications are refrigeration, air conditioning, cooking, stoves, TV, mobile, pressure cooker, and etc. And industrial applications are the power plants, automobiles, rocket, jets engine, cryogenic system, alternative source of engine, which includes wind, solar, biomass, and biomass medical applications, cooling, heating systems, fuel cells. So these are the few applications of the thermodynamics. I hope that you've understood about the applications of the thermodynamics. Now let's look at the macroscopic and the microscopic viewpoint of thermodynamics. Macroscopic thermodynamics is also called the classical thermodynamics, and microscopic thermodynamics is also called as the statical thermodynamics. So what is classical thermodynamics? A macroscopic approach to study of a thermodynamics that does not require knowledge of the behavior of the individual particles. To understand this, let's take they're having a system. In this system, we are having the few gas molecules. Okay. And we are not interested into the individual particles. We are interested into the club of molecules. Let's say we are interested into these club of molecules. What are the properties of these molecules? What are the effect that is produced by these molecules? So when we are not concerned about the individual molecules, then that kind of a study we call as the macroscopic thermodynamics. On the other hand, if we talk about the statical thermodynamics or the microscopic thermodynamics, a microscopic approach based on the average behavior of a large group of individual particles. So let's say we are having a system, okay, and this system, when we're interested into the average behavior of the particles, here we are interested into the individual particle behavior. We are interested into this particle behavior, we are interested into this particle behavior, and by the statics we apply the average condition on these molecules and obtain appropriate results. But here we are interested in the individual particle. So that kind of a study we call as the microscopic thermodynamics. And in this course, we will be mainly focus on the macroscopic thermodynamics, but to show some of the important concepts. Sometimes we use the microscopic concepts also, but moreover, we will be interested into the club of molecules or the group of molecules and what are the properties and the effect that is produced by this club of molecules. So I hope that you understood that what is classical thermodynamics and what is statical thermodynamics. Thank you.